There are two ways to name aldehydes. There's the common name and the systematic names, which are derived by following the IUPAC rules. We'll get to those systematic names in a minute, but let me talk about the common names briefly. Lots of aldehydes have common names. Of those, there are three must-know structures. Here they are. Formaldehyde is the smallest aldehyde. It pops up here, there, and everywhere, and is simply a compound whose structure you must memorize. The next biggest one is acetaldehyde. Also pops up a lot. And the third one is benzaldehyde. This is the simplest aromatic aldehyde. So if you're only going to know the minimum number of common names, here they are. If you're slightly more ambitious, I suggest you learn the C3 and C4 aldehydes as well. Propionaldehyde has 3 carbons, butyraldehyde has 4. So this very limited set is a group of structures whose common names you should know. At least formaldehyde, acetaldehyde, and benzaldehyde. Let's turn our attention to the systematic names. There are 8 sequential steps that let you name a compound using the IUPAC system every time exactly right. Step 1 is to identify the highest priority functional group in the molecule. And right behind that, step 2 is to find the longest chain that includes that highest priority functional group. Once you've done that, you can write the name of the alkane that describes that longest chain and change the name at the end to designate the functional group that's highest priority. After that, you name each substituent and place them in alphabetical order in front of the name. And next, you'll number the chain starting from the end that's closest to the highest priority functional group. Once you have that chain numbered, you indicate the position of each substituent by putting the appropriate number in front of each substituent. And finally, if there are stereochemical details to mention, add the stereochemical designators E, Z, R, or S at the front of the name. Following these 8 steps, you can't go wrong. Let's apply them to some aldehydes. Here's a simple one to warm up with. Has a single functional group, so that's the highest priority. And the longest chain that contains that functional group has 1, 2, 3, 4 carbons. So this is a butane whose name we need to change to indicate that it's an aldehyde. Butane becomes butanal. Now we're going to number that chain from the end closest to the functional group. Well, that will always be 1 for an aldehyde. We'll identify the substituents that are attached to it and put them in front of the name. There are 2 methyl groups. So this is dimethylbutanal. And we need to number those substituents. There are 2 methyls, so it's 2, 3 dimethyl, and we're home. There are no stereochemical designations to make. So take a look at this structure. It's the same structure with a double bond in it. What would be different? Well, now we have 2 functional groups, so we have to decide which is higher priority. And aldehydes are priority over alkenes, so we'll still say that it's an aldehyde as the highest priority. We'll have to use a name that indicates that we have an alkene, and we'll have to use a chain length that includes the aldehyde and the alkene. So now it's a 3-carbon chain. We'll start with that alkene name that says it's 3 carbons and change that name to indicate it's an aldehyde, put Al at the end, and to indicate that it's an alkene, we'll put the E here. So it's a propenal. Now we need to identify substituents attached to that chain, and it's an isopropyl group, isn't it? Using isopropyl is permitted in the systematic nomenclature. And now we need to start numbering the chain, so then we can use numbers to say where things are. Numbering from the aldehyde carbon is 1, 2, 3, 2 isopropyl, and 2 propenal. So this 2 tells us that the propene, the double bond, is at the 2nd carbon. Let's look at another case. I've added 1 more carbon, so this will be similar. 4-carbon chain, so we're going to call it butane. We'll change the E to Al. We'll change the A to E. The substituent is still the same, and the numbering starts at the same carbon, goes through the double bond, to butene, Al, to isopropyl. So what's different here? We're not done. We still need to show a stereochemical designator for the double bond. And to make easy assignments, you need to find the highest priority group that's attached to one alkene carbon. This would be methyl as opposed to hydrogen. And the highest priority group that's attached to the other alkene carbon. This would be the aldehyde group as opposed to isopropyl. And since these guys are on the same side, we're going to call that Z. And this is just a detail, but the rule says that that Z is put in parentheses in front of the name. Let's look at this one. We have two functional groups. The rules place the aldehyde as higher priority than alcohols. And we'll pick the chain that contains both of those functional groups. So there it is. 1, 2, 3, 4 carbons. It's butanal. Change the E to Al. We'll designate the alcohol as a hydroxy substituent. So we have two substituents on that chain, a hydroxyl group and a propyl group. We'll put them in alphabetical order. We'll number the chain starting with the aldehyde carbon and put the position designators out in front of the substituents. Now there is no need for a number between propyl and butanal, so we'll close that up. 4-hydroxy 2-propyl-butanal. But wait, that molecule has a stereogenic center. In this structure, that stereochemistry is not shown, so we don't try to name it. But when it is shown, we'll have to name it. This is the same molecule, but now we'll have to name the chirality at this stereogenic center. We'll use our Kahn-Ingold-Prelog rules to decide which substituents are highest to lowest priority. This carbon that has an oxygen attached is priority 1. This carbon that has a hydroxyl group further down the line will be 2. This substituent is 3, and the hydrogen, of course, is 4. We find ourselves going in a clockwise direction from 1 to 2 to 3. So that's the R chirality, which we'll put out in front in parentheses. And finally, look at 1 aromatic aldehyde. These guys are easy to name because we call them benzaldehydes and show where the substituents are. Those substituents will be in alphabetical order. We'll number the positions of the aromatic ring, starting with 1, where the aldehyde is attached. And we'll go around the ring in the direction that brings us to a substituent quickest. So we have 5-bromo, 2-nitro, benzaldehyde. And there you have it. Using these 8 steps, naming aldehydes is pretty straightforward.